Hey, Standoff, and let us welcome Denis Makrushin, our next speaker. So the presentation is on.
Фишками security-инструментов. И когда я внедрял Flower в инфраструктуру своей компании, то у меня была задача исключить фронтенд этого Flower, Patrowl. Patrowl — это open-source инструмент, который как раз нужен для... Коллеги, всем привет.
Good day, colleagues, ladies and gentlemen. Before I begin, I'd like to check you're there with us and how interactive you are, despite this days of full of content. So give me a plus in the chat who does blue teaming or loves blue teaming or would like to be involved in blue teaming or turn to the blue side. So put plus into the chat. And also put me a plus if you hear me. It's a bit of social polling of the audience before we switch over to the presentation. And while you're putting your pluses into the chat, I'd like to point out that most of you are most probably work with blue teams, because those who attending conferences are most probably members of blue teams, which is pretty straightforward and logical. It's just that companies, only big businesses, those who really understand how mature their security level is, can afford hiring red team. The next question is to red teams out there. If you're a red team, send 2 pluses in the chat. If you're experts in red teaming, if it's your professional sphere of activity, and you analyze security, while you're searching for the ways to input 2 pluses into the chat, most probably we'll see something like that. We'll have more blue team guys than red team guys. Well, it's just something that that comes out of my head, but it is very much in line with reality. We have more positions related to detecting attacks, related to infrastructure security or product security or such like. However, if we now have a look at red team and blue team related success, then statistic would look differently. Thing is that information security industry is asymmetric. If we work as red team members, we have enough opportunities to study our victim, to get recon and to study its profile and get ourselves ready, right? So it's enough for us to be successful only once. Red teams only have to break infrastructure once to compromise a business process or the whole organization, while the blue team, those involved in product security, infrastructure security, have to be successful 24/7, virtually every time, anytime, anywhere. Here, blue team success depends on whether or not they're nimble enough, they're fast enough to react and respond to attackers, and they can only study the attacker in the process, in the course of the attack, not in advance. Now, my presentation is about how we, the security engineers, the blue team, can become victim to the attack, red team or real life attacker. The stories I'm going to tell you is about the wrong ways to organize product security that becomes entry point for the bad guys out there. My name is Denis Makrushin. I'm head of advanced security research at Hawaii Advanced Software Technology Lab. And my experience, my previous experience, is related to realizing product security strategy. I looked at various products used by security engineers, product security engineers, and I had a chance to give it a thought and think about it, putting my red hat on, realizing that if you configure it wrongly and do something wrong, this could lead to becoming an entry point. A small disclaimer here. I had an experience of looking at healthcare institutions. About 3 years ago, I got interested in healthcare IT infrastructure security. And while I was doing this survey, I analyzed a lot of healthcare and pharma institutions, a lot of equipment of those organizations, and it turned out that their security levels, for reasons that I think I don't need to explain, the level of security is very low. There are critical vulnerabilities in the systems of e-registries, things that handle all kinds of medical equipment and devices. So in the process, when we would find those bugs, we would address healthcare institutions, IT organizations. We would submit those bugs and tell them how to close those bugs, and they would say, oh, okay, so what do I do about it? What do I do with this SQL injection? What do I do? I'm not a developer. All I can do is to swap this software with a different kind of software. And we devoted a lot of time to that. We talked a lot with administrators and developers from medical institutions, and hopefully we managed to raise their awareness. And we even made a medical village on a Positive Hack Day the year before last one. And that's when it dawned on us that probably we're talking to the wrong people. Probably we should talk to administrators, but not administrators in the medical institution, but rather those who develop software for medical institutions. So according to basim.com, those who develop and those who develop software for medical institutions are different people. And it turns out that products that are made for medicine and healthcare, those who do it, they don't understand the specifics of the business, and they don't understand how they actually are used downstream. So it dawned on us, it was an insight that it's not the healthcare institution we should talk to. We should talk to those who create the problem. Healthcare is your user, and you should save the user. So we realized that we should probably focus on the development process and look at whether or not there are any kinds of flaws and vulnerabilities there. Before going further into it, let me talk to you about Agile and Agile Security as an approach to developing product. I've never seen Agile, but I know that it does have certain principles. So flexible product development is about don't reinventing, make use of things that were previously invented by somebody else that have been published and used earlier. Improve those inventions, do it incrementally, and follow and make sure you watch what you do, and also automate it. Why use human resources if you can use automated tools, automated frameworks, so that we free up people to do something more creative? So same principles are used by Agile Security, integrated into product development process. So all these three principles bring in three elements into security development and product development: new processes, new methodologies, new pipelines, new branches like CI/CD and other tools that we use to continuously improve the product and bring it to the market. Then new experts, new people who say they're experts in DevOps, DevSecOps, and other ops. Those were earlier. Those were separated. Now they are all united. And additional tools that are included in our business process. So if you come to an organization and you're asked to look at, improve, and analyze product security or application security, you would see something like that. You don't know who is in charge of what. Nobody really understands where the responsible people are, who is in charge of fixing this bug and when and why fixing it. Total mess. Nobody understands what's going on really in this institution. Who is this DevOps person? Is he or she in charge of this part or that part? If there were no process in place before you on your predecessor stage, well, you're in bad shape. If you're looking at automation, the situation is even more blurred. You see frameworks, and platforms are built on those frameworks, and these frameworks call to life certain tools, and some of these tools fly, others don't, and they stay as rudiments in the system. So something is updated, something is forked, and to put long story short, they expand attack surface. And before talking more about attack surface, let us talk about our definitions. Attack surface can be explained in this way. Host behind the firewall is separated from host 1 and host 2 with various servers. If we take the firewall away, then the attacker will have to make several steps from host 0 to host 1 and host 2 in order to gain the secrets stored on host 1 or host 2. Number of steps to be done by the attacker. If we bring the firewall back on, then the bottom picture is the one you need. Additional steps, right? We need to, as an attacker, you need to take additional steps to get to the data on host 1 and host 2. And this is the attack graph that you get. If attack surface is just a sequence of steps needed to be taken by the attacker to gain his secret, then this would be it, the attack graph. And now on to the attack surface that I was referring to. Any tool that we as specialists in product security, any kind of security, the blue team that we introduce into business process for product security purposes or infrastructure security purposes, they change this attack surface just because we add something. Us as people and the rest. So if we look at your typical product development, you can see what a security engineer changes. Let's look at classical 3 stages of product development. First one, when you come up with a code, your developer and your security engineer would say, okay, thanks for the code, we're going to test it. So security tests, SASTs, right, static tests, is when we check just on the code level, right? Next thing is when it turns into a prototype, the staging, when it has final look or pre-production, gets to pre-production stage. And this is where a security engineer says, okay, we are going to test it dynamically, the tests, the fuzzers, and all that. And finally, when it is already being used, then security engineer would say, okay, on this stage, we are going to carry out continuous pen tests, penetration tests, red teaming. We're going to put it on bug bounty program. So if you look at all these 3 key stages, the specialist in product security would change something on each of the stages. So getting back to our big company, where we try to protect the product. If we scan the enterprise network, internally or externally, we'll see multiple elements. This is your typical attack surface of a typical enterprise company. Tons of assets, some are products out there, public-facing, online. Others forgotten by everybody, but still working and referring to certain IPs, intellectual properties. A lot of ways to touch you. External and internal attack surface is huge. So if we now try and describe the reason why so many assets are out there in your enterprise network, one way to suppose it is that everything is changing. Somebody would come and configure it the way he knows and then leaves the company, and a new person arrives, he doesn't understand what's going on, and he starts from scratch. So these processes put forward certain forgotten things, forgotten resources. So let's try and split this variable hosts and resources into three major categories that I referred to you earlier. First block related to development. Second one was quality assurance, code analysis, and then everything related to the product, operations. So, but before going to analyzing this kind of instances, let us vote, put plus in the chat, those of you who think that commercial security assets is something that you would like to use. And if you are free to choose what to use, open source or commercial security assets, you would prefer commercial security mechanisms or tools. Plus to the chat, those of you who think that they should be used. If you are all for commercial tools, that they should come first and the open source second, put a plus in your chat. And I'm putting my plus into the chat. I think that we should have commercial products on the inside because you as a specialist share responsibility. I mean, if there's a service to it, then the vendor signs SLA with you, right? You share responsibility with him, and if vulnerabilities are identified, you know whom to hold accountable. In this way, commercial security product is a must. Okay, you don't have to agree with me here. Let us start with commercial mechanisms, commercial tools. Let's take code stage as an example. When product code merges and you want to analyze its quality and its security state, application security guy comes and says, we want to use SAST on you. SonarQube is not your typical SAST. It's rather a code analyzer that checks code quality, while security is just a byproduct. Yet, SonarQube is something that is oftentimes used to check code quality and security, you know, the basic check for security. According to Shodan, if you use the search request port 9000 SonarQube, you'll see that there are a lot of installations out there. Well, it doesn't mean that it's authentication-free, but still, oftentimes, you see installations that don't ask for any authentication. You can just enter and go ahead and look at, okay, which the code that was implemented or SonarQube that everybody forgot about and you can use for your own purposes. But you don't even have to browse across those SonarQube to understand that it's necessary to be protected. If you now open GitHub and you carry out GitHub scrapping and try to search for secrets related to SonarQube in open repositories, you'll see that if you introduce SonarQube ePass or any key pass or anything related to keystrokes or passwords, you'll see that a lot of specialists synchronize their scripts and push those scripts into GitHub. And I think it's not really a good idea to do it in public repositories, and you don't want to do it in GitHub if you have a script related to a business process, right? You'd rather do it internally. And people forget to delete credentials, and those credentials can be found open right there in GitHub. And if you remember the third principle, Agile, automate, right? And product security guys oftentimes automate. SonarQube has CLI integration, so you can write a script into online command line. And if you open SonarQube documentation or any other solution for that matter, and you find anything interesting related to authentication and authorization, you can use those keywords to find scripts that are authenticated on SonarQube. See? And we have this keyword sonar.login. We carried out GitHub scrapping using this keyword, and it turned out that GitHub leaves their automation scripts right there on GitHub with all their passwords and credentials. It doesn't have to be SonarQube. Any other Gartner Quadrant companies with commercial products that was easily found in Shodan or in Google, you'll see installations, and almost all of them, in all of them, you have to enter your username and password. But creating new account is oftentimes not disabled. So you can easily create a new account, get by default privileges, and those privileges would allow you to look at elements of IP, elements of code that SaaS, DAST, or security solution works with. And you can make use of an expensive tool, an expensive commercial tool to scan your IP, which is crazy, but I mean, this could be done. You can change the scanning logic. You can introduce your scope for scanner. And let me reiterate, this is an expensive thing. Not every commercial company, not every enterprise can afford it. And you can just take it from GitHub. Besides, according to Agile principles, you have to do automation, right? Command line integration included. So we scan these repositories for all kinds of secrets related to product peculiarities. So we search for them using keywords related to authentication, authorization, and all that we got from the commercial product manuals. So for us, for Blue Team, for security engineers, there's a set of rules on how to avoid this and how not to change attack surface if you want to introduce SaaS and DAST. First off, you don't want to make it readily available in the internet and readily available to get an additional account. We need to review every new account. What if you come to an already existent infrastructure? Then you should turn into Red Team. Put your Red Team hat on and assess the attack surface. Get all the tools available from the outside and from the inside, and make sure they're configured, that they're updated, that people use them. It's not that something that's long forgotten. And all the steps have been enumerated already, and this way you should control the attack surface. Remember my previous question? So now put 2 pluses, those of you who love open source and who don't want to use anything but open source, who believes that open source security solutions are top class, are best, and this is something that you should use. If you have to choose, you would want to choose open source. And why? If you're all for open source, tell me why. Well, on the face of it, it seems like community is behind open source and it's held accountable. But in fact, I think community may as well ignore your call for action, while vendors have signed this SLA, so they have to act. If we take open source solutions, because not everyone can afford using commercial tools, we'll find a lot of interesting stuff. And those who call themselves DevOps and those involved in security and development change attack surface considerably. This one is Microservices tool called Flower, rather popular. Just to give you an example how easy it is for this product to lag behind in terms of security, even though the product may be popular. Here I just inputted into Google most usable DevOps tools, and one of the tops was Flower. I'm not sure if DevOps use it. Probably only just developers use it. But looks like it's being used and installed and used. And if you have a look at how it works, it's a product that's there to manage your queries and manage your queues and manage the script that stay in your buffer. If your script works with valuable data, then you see this data in dashboards. If you now look at attack surface and look at whether or not Flower is popular in open sources, you'll see a lot of Flower installations that are readily available from the outside. You can touch on it and even not updated. We are going to look at the updated version, however. When I opened this Flower, I wanted to have a look at it and what's there in it and can I dig into it. Didn't find anything interesting with only one exclusion, one field. And I had this déjà vu moment. I've seen it somewhere. I looked at my rotor, and it only had one entry field, and it was the base XSS vulnerable. And when I started to dig into it, turned out to have a lot of bugs, a lot of hidden credentials, etc. So the only field vulnerable to XSS made me think that, okay, if this thing has something as obvious on the surface, then if you dig deeper, you'll find something even more interesting. And then attack surface that consists of all those who makes use of Flower in their infrastructure may mean that they are theoretically, they can theoretically be attacked. It's not really thrilling to look at DevOps interesting because us as security engineers are a more interesting target. So I decided to go to security engineer tools like infrastructure security guys or product security guys. There is this category of system called security operations orchestration platforms. Their business task is very straightforward. If you have a plethora of solutions, antiviruses, firewalls, WAFs, and all that, you may want to make use of this orchestrator to process an incident. Say you have a detect on endpoint. You want to send a playbook, a scenario when you detect something in an antivirus. So you want to send information to firewall so that it detaches it from the network or something like that. More often than not, this orchestration is needed for major companies that have heterogeneous infrastructure consisting of various vendors, various systems, and it's reasonably, it's working reasonably well because you don't have to manually do something about it and launch multiple scripts that work with IPs of security instruments. So when I introduced Patrowl into infrastructure of my company, and this is an open source tool, the open source orchestrator for security solutions. And at that point of time, there were no analogs out there. I mean, no other open source non-commercial solutions that would really work nicely. So Patrowl was the only way for me to put it into, or to put it on internally and study it. It has multiple Docker containers that has a lot of tools in it on backend and front end that has a user interface that allows you to manage all that. So I decided not to use the front end. I wanted to do something on my own. And while I was doing this something on my own, it turned out that all the containers that would take commands from UI would never check these commands. And anybody who could reach that container could use Nmap, and Nmap was the by default engine inside this product, could use this Nmap to sign a random command into it, and nobody sanitized the string that would come from dashboard, because dashboard was a trusted source. An interesting question was, okay, how many people makes use of those externally, of this thing externally, and may by default put this container on? It actually opens remote code execution for anybody who would be there to find it. And it is so. But for developer, it would have been a very obvious problem. And we started to study the code, and it turns out the developer knows of it. And he mentions sanitize it on your own. Container would take a command without sanitation, and you sanitize on your own, which definitely means that even if the author of an open source instrument knows of a problem, it does not necessarily mean he or she is going to resolve those problems. Just to give you an example of how these containers with Nmap can become an entry point into the cluster whereon the solution is run, or at least compromise the point to mine bitcoins for a Trojan. Speaking of containers, we love to bring the pre-configured thing behind the Docker Hub. Use a container. A container with web server used as a proxy or as a load balancer. And then, even though we protect our product and we have design review and code review and all kinds of pen tests and security assessment of this product and bug bounty even, continuous security is there for us. But if we would download a container from open sources without checking what it contains, then we're at risk of making this container an entry point into our product. You may download a container with web server that has an opportunity in it to enter random headers that would be sent further. And host header can get host header can get reflected somewhere if those strings are trusted strings. So this trusted string would be put by our application into its page. If there is no sanitization, then payload may work, JavaScript code, for example, or you may poison a cache. This is a real example of an attack when a payload is put into a cache, and then this payload is distributed from server cache if this cache is not tuned correctly, and if this cache is given to all the internal employees without additional checks. Yes, it's a difficult scenario, but such container could be used and used for targeted attacks, the attacks targeted against those working with this product. And by the way, security specialists are oftentimes objects of attack. And you would say, we are not interesting. We have HRs, we have finance people who don't know how to go about security, who are careless about their workstations, and it's best to penetrate through them. But those who are not, who don't know a lot about security are a bit more paranoid than you guys. They realize that that they may become a victim of attacks, and we carry out the we carry out our phishing checkups and raise their awareness, and they realize that they may become object of attack. And what if the target of attack is security specialist that is careless, or let's say not paranoid enough? This is example of a pen test. We send a a ticket where we only mentioned that something is not working, a very primitive social engineering thing, and the link inside this ticket would go to Brook Collaborator. we could collect the profile of those who followed this link. So in several days after we put this payload with instance of work collaborator, we could see certain queries. And then it was given the title of phishing. And this is the insight that you can use to develop your own attacks if you belong to red team. So if our ticket was processed by a security engineer, a product security specialist, security engineer, not in a sandbox, but right from its workstation, then we had an opportunity to compromise that workstation, to drop payload there, to redirect it to a phishing site. It might have not worked, but still it hints that security guys can well become victims of attacks from a red team or even other scary people, the adversaries, the true adversaries. So here are the recommendations. If we are saying that we work in security vendor and we develop products for product security, and if we're involved in DevOps and DevSecOps, then first and foremost, we also should have SDLC in place. We need to carry out reviews and look at our product from the point of view of not just code quality, but also code protection. So secure SDLC processes are as relevant as ever for us. So this is our top priority. Secondly, we need to educate our users. We need to provide them with information that if they use our product incorrectly, that this very product not only does not protect him, but even makes into an entry point. So scanning perimeters, checking whether it's a demo stand there and whether the product is used correctly. This is something that should be done. And using OSINT open source intelligence techniques to make sure that the product is installed properly with us and with our customers. Another set of recommendation goes to security engineers, not security vendors. If we change anything in the system, when we come to this company, we already changed something in terms of processes. So, and we want to understand, to make sure we're not being destructive, we need to look at know your attack surface. We need to play the role of red team and assess our own work and look if something goes externally. If yes, and if it's necessary, then probably you should close it with authentication. You need to account for all the subtleties that I referred to earlier, and we need to bear in mind that we may become a target of attack. Our product may become vulnerable. And the links that we open might also contain certain phishing intents. So don't click through links and create your own code of conduct. Not just security researcher code of conduct, but anybody related to security and product security. Those who work with products and who change anything related to security, thus extending its attack surface. And finally, this is actually top priority. If we love open source, and we do love open source, then we need to check open source. We need to implement things related to third-party component checking, library checking, checking any product that doesn't have a dedicated vendor or a dedicated service-level agreement. We should either check it on our own or use best practices out there in this industry that allows us to monitor it continuously. One of such monitoring opportunities is CodeQL, an LGTM tool from GitHub. When you just put the open source products and libraries inside the system, and it tells you what goes on with each of them. Any new vulnerabilities, maybe new vulnerabilities have been identified, so you follow this open source like by way of passive monitoring. And if it turns out that a new commit of this product, say, contains a certain bug, then you have a chance to introduce changes. And the most important recommendation I started my presentation with, we can change our attack surface, and we change it. So at one point, we can become a victim, although we are the people involved in security issues. Even if you say, I'm red team, I'm the one who does it, you may be compromised as well. Even if you are the attacker, people may come and put this bucket on your head, just like that. So follow your tools and stay assured that we may become victims of attack as well. Thank you very much for your attention. I'll be happy to take your questions in chat, and let's keep in touch. Thank you.